So you start from, so you increase the value of occupation probability. Then what is happening? And the thing we have learned so far is that for a particular value of P, the cluster number density roughly corresponding to the probability density of the cluster with the size S goes like, no, or with this particular characteristic size of this one. And because this is increasing function of P, larger value of P allows larger and larger cluster, given by this exponential dependency. Another important point is not just increasing, it has a singularity at P goes to 1. And the singularity is, of course, the logarithmic singularity. But if we use the Taylor series expansion, we can guess this goes like 1 minus P to the power of minus 1. Yeah, this is the summary of all the things we have learned from this one-dimensional system. So nothing is that dramatic so far. And the only weird part looks like this particular point. But at the same time, I mentioned that for other dimensional cases or other example, the critical point or the singular point is very interesting point. But one particular interesting and kind of weird thing about this one-dimensional system is that this point is actually, you already know, this point is trivial point or not quite interesting point. But I think you already know that this P equal to 1 and P goes to 1 is actually different, the limiting behavior. So this is kind of critical. So again, this is kind of weird coexistence. As P goes to 1, it looks like it converts to, or it approaches some kind of very critical and power law-like behavior. But at the same time, if you actually use this trivial case, nothing is interesting, because this means that basically all of the sites are occupied and nothing comes up. So it's kind of weird combination is a characteristic of this one-dimensional system.